Hello students, welcome to this video. This is the third video for lesson 8, Solve Systems of Equations Algebraically. There are 4 videos for this lesson, and in this video we are going to solve example 2 on page 245. In this example, we are asked to solve the following system of equations. Okay, to do so, we just follow the same steps as the previous examples. We need to look at the system of equations that we have here. There are 2 equations. Okay, by looking at these 2 equations, we need to find the value for one of the variables here. For one of the variables, which of these equations gives us gives us the value for one of the variables. We can see from looking at the first equation that it gives us the value for y. We can know from here that y is equal to how much? It's 3 times x plus 8. 3 times x plus 8. This is the value for y. Okay, how can we use this value to solve this system of equation? We can just take this value and substitute it where? In the other equation, which is the second equation here, and replace the y here with its value that appeared in the first equation. By doing this, we are finding the value for x, and then we can just substitute again in the same equation and get the value for y. Let's do it. To do so, we just rewrite the second equation. We have the second equation here to be 8 times x plus 4 times y equals 12. Just rewrite the equation as it is. Okay, now which variables in this equation do we know? We know the value for y. How do we know it? From the first equation. It is given in the first equation here. Okay, so we know the value for y. What do we need to do is just to substitute in this equation. So we have 8 times x plus 4y, but instead of writing y, what should we write? We should open 2 parentheses, and between these parentheses put the value for the y, which we just solved here to be 3 times x plus 8. So we can replace it like this: 3 times x plus 8. Okay, now what is this equal to? Just continue to write the equation as it is. So we can write it is equal to 12. Okay, this method of taking the value of one of the variables and substitute it in the other equation, okay, this is called substitution method. The substitution method of solving systems of equations, algebraically, of course, not graphically like previous lesson we have, lesson 7. Okay, we just now need to simplify this equation here and solve it. Solve it for whom? For x, of course. Find the value for x. To do so, we need first of all to get rid of these parentheses. These red parentheses. How can we get rid of them? We can just distribute the multiplication of 4 over the numbers or the factors between the parentheses like this. So we need first to multiply 4 times 3x, then 4 times 8, okay, which will give us the following results. Let's do it together. 8x remains the same, nothing for now we can do. Okay, so we write 8x plus 4 times 3x. Multiply the factors together. 4 times 3, 12. 12x plus 4 times 8 is 32. Okay, this is equal to how much? 12 remains the same. Okay, for this equation here, we can see that we have the same variable here. We have 8x and 12x. It's like saying we have 8 boxes and we have 12 boxes. How many boxes do we have? Of course, we can add them. Then we have 20 boxes. Okay, so it's like saying 8 plus 12 gives you 20 times x. Okay, and this is plus 32 gives you 12. Now this is a simple equation and we all can solve it, right? First of all, we need to get rid of this 32. It's positive, so we need to subtract it from both sides of the equation. From this side, 32 minus 32 is equal to 0. And here, 12 minus 32, how much is it? We just look at the signs. We can see that there are different signs. So we put the signs of the greater, and because of there are different signs, we just subtract them. So 32 minus 12 is equal to 20. So we will left with, what is the equation now? It is 20 times x equals, this is 0 or plus nothing, so we can just skip it. Okay, 20 times x equals negative 20. What is the last step that we need to do to solve this equation? Just to divide, because it is a multiplication between 20 and x, we just reverse the mathematical process and divide both parts here over 20. Why over 20? Not because of this negative 20. It's because 20 is the factor for x. So here we got 1 and here we got negative 1. So what is the value for x now? We can see that x is equal to negative 1. Okay, so we did it. We found the value for x. Now, how can we use this value to know the value for y? We know what is y, right? We know that y is equal to 3x plus 8. So now we know x. Now we know the value for x. Okay, this x here. So we can just take the value for x from here and substitute it in the first equation to get the value for whom? For y. Okay, let's do it. So we need to substitute it in the first equation, or we can, of course, substitute in the second equation. We can take the value for x from here and put it there, and then solve the equation for y, so we can know y now. But it's easier to substitute in the equation that we used first time to identify the I value, or the y value, sorry. Or you can, of course, substitute in any of the equations, no problem at all. Okay, so we know from the first equation that y is equal to 3 times x plus 8. 3 times x plus 8. Now we know the value for x. What should we do? We should rewrite the equation again. Y equals 3 times x, but this time, instead of writing x, what should we write? We should open two parentheses, and between these parentheses, put the value for x, and how much is it? It is here. From there, it's negative 1. Okay? And then just continue the same equation as it is. It's plus 8. Okay, what do we do first? We add with 8 or we multiply? The multiplication comes first, of course. So it is y equals 3 times negative 1. It's negative 3 plus 8. How much is y now? Y is equal to 5. So we have just solved this system of equations, and we can represent the final answer in the green box here. We can just write it as a point of intersection between the graphs for these two equations. So if we graph these equations individually, if we graph the first equation and then the second equation, the intersection point between them will have the following coordinates. The x-coordinate of it will be negative 1, because we found x to be negative 1, and the y-coordinate of it will be 5. Okay, so this is the final answer of the system of equations here. This is the solution for the system of equations. Okay, let's check now that our answer is correct. Let's check that our answer is correct. For checking, I'll just keep it for you. You need to just take these two values and substitute it in any of the equations, and you get an identity. Okay, if you got an identity, then your solution is right. Okay, let's go to solve got it from the same page below this example. Okay, the got it questions. Let's pick one question of them to solve it. Let's solve part D. Okay, so we are going to do got it exercises on page 245. We are going to solve exercise D. Exercise D. I'll left the first one for you. Part C, try it at home. Okay, we have a system of equations again, and we need to solve it. We need to look at these equations. Which equations gives us a value for one of the variable? Of course, it is here the second equation. We can see that y equals how much? We don't know the number, but we know an equation that represents the y value. So here, y is equal to 6 times x minus 4. So we can use this value and take it, substitute it in the first equation or in the other equation by replacing y with that value. Okay, we can replace this y with the value just mentioned in the second equation or given by the second equation. Okay, to do so, we need here to what? To rewrite the first equation again. Rewrite the first equation again. As we did before in the previous equations, we just rewrite it 2 times x plus 5 times y equals 44. Now rewrite the equation again and substitute. This is a substitution method, so we need to substitute something. What variable here we know? We know y. So we need to rewrite the equation, but this time instead of writing y, what should we write? We should write two parentheses, and between these two parentheses we put the value for y. And how much is y? It's 6 times x minus 4. So we put it there. 6 times x minus 4. Okay, this is equal to how much? It's equal to 44. So the same steps as before, just distribute the multiplication over the numbers or the factors between the parentheses, and then we have 2 times x plus 5 times 6 times 6x, which is actually 30x, minus plus 5 times negative 4. How much is it? It's negative 20 equals 44. Okay, here we have two variables, the same variable. Okay, we have the same variable here, 2x and 30x. Two boxes and 30 boxes. What is the addition of them together gives you how much? They give you 32 times x minus 20 equals 44. Okay, and this is a simple equation. We can solve for x. We can just move the 20 first. Okay, and here we got 0, and here just add the 20 to 44, which give you how much? It gives you 64. So the equation became 32 times x equals 64. Can divide both parts of the equation over the factor with x here, and got how much? 64 divided by 32 is 2. So we got x equals 2. X equals how much? 2. This is the value for whom? For x. We can take this value for x and substitute it in the second equation to get the value for y. How can we know the value for y now? Because we know the value for x, we can just go to the second equation, which gives us the value for y. Y equals 6 times x minus 4. Now we know how much is x, this one here. So we can write y equals 6. But this time, instead of writing x, what should I write? The value for x, open two parentheses and put that value. How much is x? It's 2. So we write here 2. So the equations become y equals 6 times 2 is 12 minus 4. So y is equal to 8. Okay? How can we represent the final answer or the solution for this system of equations? Let me write it there in green. 2 points. It's a 1 point, okay, 2 coordinates. The x coordinate is 2 and the y coordinate is 8. And that's it.